Hello everybody, in today's lesson we're going to be talking about the basics of integration. And so first of all, what first thing you need to know is that integration is written with a elongated S symbol, something like that. And what is the only difference between integration and derivatives is that integration is the opposite of derivatives right here. So for example, if you want to take the derivative of, let's say, x squared, make it simple. X squared, you want to take the derivative of this. So a function of that derivative, x squared, is equal to 2x. Well, what will happen with integration? If we're integrating x squared, that will be the entire, it would essentially be the opposite form of derivatives or an antiderivative. So we do dx because we're taking the integration for x. So we essentially work backwards. So it's half times x to the power of 2 plus c. No, x to the power of 3. Sorry about that. Over 1 over 3. Now you might be asking, why is it this notation? This essentially, integration is essentially antiderivatives. So because when we work it like that, when we take the derivative of this notation, we get 3 times 1 over 3 x squared plus c squared, which will just be x squared. So we go back to derivatives. So it's essentially working backwards from derivatives. That's it for integration. Now, lastly, what you need to know for integration is that the uses of it. So pretend we have a curve like this. This is f of x. And you want to figure out the area under the curves. Integration is really useful for that. So you could imagine it as slices. So like each slice to represent the area. And if the slices are infinitely with a width of infinite or close approximately 0, then you essentially have a really smooth bell curve area. So that's what integration is really good at. So what just to recap, derivatives are essentially slope. Integration is what is essentially under that slope, right? So now that we have this out of the way, we can do another key topic of integration called definite, and indefinite integrals. So how do you know that definite integrals are integrals that are clearly defined within the range? So for example, going from a to b. So one example of this can be if you have a graph like this right here, you want to figure out the area underneath a to b. So you're figuring out this area right here. Now an indefinite integral will just be if let's say f of x, and taking the integral for x. Well, indefinite integral can be any because it's not clearly defined, so it can be from this whole thing, or we can take it back and then just go to here, etc. It can be anything essentially since it's not defined. So that is the introduction to integrals.